woman in a ranger uniform at the edge of a lake. Mountains in the background.
Hello, welcome to Glacier Science Day. And I'm standing in Two Medicine, which is in the southeastern part of Glacier National Park. And behind me is the beautiful Two Medicine Lake. It's a sunny day, gorgeous. It's probably in the low 50s. And I'm so excited to be here today because we're gonna meet up with a wildlife biologist. Leah Joyce is getting her PhD in wildlife biology at the University of Montana in Missoula. And she is studying some very interesting things. She's looking at frogs, toads, fungus, and beavers. I don't know, but we're gonna learn a whole bunch from Leah and what her research is showing. So let's get going. Come on.
Leah Joyce squats at the edge of the lake. She collects water in a cylindrical device.
Hey, Leah.
Hey.
Oh my gosh. I found you out here.
Yeah.
How are you?
Good.
Welcome to Glacier Science Day. We're so excited to meet with you today and learn all about your research. It sounds fascinating. I can't wait to learn more about beavers, amphibians, and fungus.
Great.
So what are you doing right now?
Well, I just got here, so perfect timing. The first thing we do is measure water quality at all of our sites.
Okay, is that like a thermometer you're holding?
Yeah,
or?
so this is our pH meter.
Oh, pH.
It's a nice little cylindrical meter that's really easy to just insert right into the water. It's got a little probe down at the bottom, this little circular piece.
Cool.
She demonstrates.
So we can just stick it right in the water and it gives us the temperature, the pH. We know that in particular the fungus that we're studying can be affected by temperature and pH in the water. So,
and the fungus is called?
Kindred fungus.
Okay, and that's affecting the amphibians that you research?
Yes.
Okay.
This fungus is in the water and it lives on amphibian skin.
She holds a toad in her hand, then swabs it.
And so
can you see it?
No, we cannot see
Okay,
it.
it's not visual to the eye.
Nope,
Okay.
It's too tiny and there are unfortunately no obvious signs of infection. So we basically come out and we catch a frog or a toad and then we swab it.
Oh.
And then we'll preserve that little swab and we test for the Kindred fungus DNA on that swab.
Oh, wow.
So when we swab the frog or toad, we can pick it up off their skin if they have it.
What are you finding here in Glacier? Like, are a lot of our boreal toads and our Columbian spotted frogs affected by this?
Yes, they are.
Oh, okay.
Yeah, we've checked about 45 wetlands across the east side of the park.
Okay.
And we found it in every wetland. But with the toads, we've been looking at their populations here in these ponds over the past 10, 12 years.
Okay.
And we found that when a toad is infected with Kindred fungus, that increases its chance of dying by 20%. They're still surviving with Kindred fungus and it's not causing crazy population declines like we've seen across the US and in other countries.
Wow, how fascinating. So something is a little different here than in other places. That's amazing. And that's one of the things that you're working to figure out.
Yes.
Okay, so I want to go look for some. Can we do that?
Yeah.
Awesome. I hope we find some. Let's go.
Woo.
Leah walks on a trail. She stands in a field with Ranger Melissa with a toad in her hands.
A healthy male. And then...
this is so cool. So it's a boreal toad, folks.
Leah holds a scanner next to the toad.
And we've caught this guy before.
Oh, wow. So this one has one of the chips in it?
Yeah. So...
What are those called again?
pit tags.
So he's got a pit, this boreal toad has a pit tag in it.
The scanner displays a number.
So the tag in this toad is just like the little microchip in a dog or cat. And so you can scan it and you get basically an individual ID for that specific toad. And so right now we just know the ID number. So but if we go into the computer system and enter this code, then we can see how large this guy was in previous years when we've caught him, how often we catch him, if he's at this wetland or different wetlands.
And how did you know it was a male?
So this little guy makes a little peeping sound, which, there we go.
Oh my gosh. Oh, you little buckaroo. Oh my gosh, that's so great.
So that's what we call a release call.
Okay.
So females.
He wants to be released.
Yeah, yeah. This is a let me go. So females don't make any noise. So when all the toads come out in the spring to breed, they basically just grab on to the first toad that they see. And if it peeps, then they know it's a male and they should let go.
The back of the head.
I noticed there's like a little white stripe, and that is one of the indicators.
Yeah, so this white stripe is one of the indicators of boreal toads. That's how we can tell this species from a lot of other toad species. And this guy, usually it's a lot more pronounced, but this guy's got a pretty light white stripe.
It looks healthy, but now you
It
don't.
could have Kindred fungus.
It could, and so how would we test for that?
So here's our sterile swab. It's in this packaging so that we know there's no DNA or dirt on it that could prevent us from detecting the fungus DNA.
So that's really important to not have anything touch it.
Yeah, and that's why I also wear gloves. It's not because I'm afraid of getting warts from the toad or anything if he pees on me, because that's a myth.
Oh, is it? I didn't know that.
But it's actually to keep my DNA off of the toad so that we can pick up that Kindred fungus DNA.
Swabs the belly.
And that's where you're going to go right there. You get on the belly.
So we try to get the belly.
Between the leg and belly.
This is called the drink patch, this area down here. And that's where their skin is a little thinner and where they can take in a lot of nutrients and water from the ground when they plop down on the ground.
I didn't know they could do that.
Then we also try to get just their hands, their arms.
He's kind of getting a massage.
Yeah,
right
it is
now.
a little massage.
Yeah.
So now I'll trade you for the trash.
Okay.
And I will just
Gotcha.
Leah puts the swab in a container.
Open that, put the swab right in there. So we'll take that into the lab and look for Kindred fungus DNA. Frogs and toads rely on their skin. Remember this little drink patch here? They rely on their skin to uptake a lot of nutrients and water, and so they need their skin for their electrolyte balance. And the Kindred fungus actually attacks a little protein in their skin, and it causes this electrolyte imbalance, and then they go through cardiac arrest. So it's like their heart shuts down. And so when we see a dead toad, it's just dead. There are no outward signs of how it could have died. So it's kind of cool. This guy could either be covered with Kindred fungus or could be totally healthy, but we have no idea.
And that's why you have to take the swab.
Yep.
Leah holds a frog.
Okay, so now here's a Columbia spotted frog. So this pattern on the side here. Sometimes we've got a cool little pattern on the top.
Yeah.
And then another characteristic. So we've got this little spotted mustache.
Yeah.
And these red legs and the red belly.
Oh, man.
So, yeah, this is a
cute.
pretty typical Columbia spotted frog. We don't tag the frogs here like we do the toads.
The pit tags aren't in these because you're not tracking these as much because they're not doing as poorly from the Kindred fungus.
Yeah.
Okay. But they get it. They do get it.
Mm-hmm.
Okay.
Yeah. They're just, we call it more tolerant to the fungus.
So they can do better.
Tolerate it better than the toads. With the toads in particular, they're found all through the Rocky Mountains.
Okay.
But they've been wiped out in the southern Rocky Mountains, we think due to Kindred fungus. But they're
not
doing okay up here.
So Leah, I have learned a lot about how Kindred fungus is affecting Columbia spotted frogs and more importantly, the boreal toads. But in the beginning, we talked about how you're also looking at this other fascinating piece about beavers. And right here, you just told me there's an active beaver lodge.
A beaver lodge. A beaver swims underwater.
Yeah.
And all of these ponds are basically created by beavers. So how is that piece related to the amphibians?
Yeah, so we know that beavers can change the landscape, and if you think about it, it probably used to be a stream flowing through here, but now we've got this beautiful, huge wetland. And so my project is looking at how the creation of these beaver ponds affects Kindred fungus infections in amphibians. We have seen in previous studies, particularly here in Glacier National Park, that we were more likely to find toads and frogs in beaver ponds than non-beaver ponds.
Okay. And then after you get all the data that you've been getting for, you said 3 or 4 years, then you're going to create a model. And what are those models going to show us?
They'll be able to show us, hopefully, how beaver ponds are affecting chytrid fungus, if toads are more likely to have chytrid fungus in beaver ponds than non-beaver ponds.
Okay.
And then also looking at the two species together. So are we seeing more chytrid fungus when frogs and toads are in these ponds together, or if just frogs are here, and so forth. So there are a lot of questions that we can ask and answer in this system, which is really neat.
Why are they important? I mean, why do we need, you were talking about boreal toads dying out essentially in the southern Rocky Mountains. Why are they important to have in a wetland environment? Why are frogs and toads a part of this ecosystem in a way that changes or not changes it?
I would like to think that they're really important parts of the ecosystem. They've been around for 350 million years.
Whoa, wow.
And yeah, so they've been part of the landscape and a part of the food webs that are here for a long time. Earlier in the summers, if you come out to a wetland, you'll likely see just these mats of thousands of tadpoles hanging out.
Whoa.
And they play a huge role in nutrient cycling. They eat a lot of the dead and decaying material and algae, also mosquito larvae.
Wow.
So yeah, they're
a huge component.
Yes, a huge component of these wetlands.
She holds a toad in her hands.
So I just learned so much today. I loved seeing the frogs and the toads. I love just thinking about them here in this environment and all the amazing things we can learn from them. I'm hoping that we learn more about your data and the models that you're going to create. Maybe we can check back in with you at some point. I'd love to find out more what you have found out. And, folks, stay tuned because we still have some great science videos left this season. So stick with us. Join us next time. But for now, happy Glacier Science Day!
Thanks for coming out.